Okay, 5.1 I'm going to leave as a independent exercise. It's mostly just read through the textbook and try and fill in the details as it goes. And actually, I don't have my textbook here with me, so I can't walk you through it, but if you have questions, I'll walk you through it in class. But yeah, take some time, read through the textbook, and try and fill in the sheet based on the three examples that are in the textbook in 5.1. It shouldn't be too complicated. It's basically analyzing the center values of mean, median, and mode, and how they relate to different questions, and they each have their own purpose. That's why we have all three different definitions. Each one has a different value, and then also talking about outliers and range, and some other things like that. So most of that should be review, but you should go through it anyway and make sure you understand those concepts because they're very easy to test, and if you don't understand them, you're going to do quite poorly. Okay, 5.2, we're going to be talking about frequency tables, histograms, and frequency polygons. So this is all about taking data and being able to graph it and analyze it appropriately. So first thing we're going to do is we're going to take this data here and we're going to graph it two different ways. Once with a histogram and once with a frequency polygon, which I don't think you've ever heard of before. I'd be surprised if you had, but it's not actually too complicated. First thing we need to do is make a frequency table. Frequency tables aren't too bad to do. This says it wants every interval to have a width of 450 for the Red River flow data. So the first one is from 150 to 600. I guess the lowest data on here is 150, or 150 is a fair bit lower than it. For some reason, it didn't start at 0. And then our next one is going to go from 600. You have to start at the same number. And then we're going to add 450. So that should be till 1050. Starts at 1050 and add 450, and that should be 1500. And keep going like that. Have to change pens. Let me try and finish this, and then I'll change pens. 3750 to 4200. Okay. I'm not that fast at adding. I got that from a sheet beside me. But this is just adding, so this shouldn't be too complicated. Next thing you have to do, and this part everyone always messes up, because it is quite challenging actually, is you need to add a tally every time a piece of data is in one of those categories. And the best way I found is to not go too fast and actually cross out the data when you make the tally. So the very first one we have here is 3058. So I'll cross it out, and it goes into this one right here, 3058. Okay, I'm going to leave you to do the rest of that. There's quite a bit of data. It's going to take a little while. Pause the video, take about, I don't know, 5, 6, 7 minutes, and try and tally this up perfectly. Most people end up off a little bit, but you really want to be perfect when you're tallying. Okay, go ahead, pause. I'll start talking again in about 15 seconds. Okay, hopefully you have all the data down. You've gone through, you crossed it all off. That way you don't double count anything. Your final tally should have been, if my numbers are right, 11, 9, 6, 12, 6, 2, 3, 0, 0, 1. And again, this is an indication of how many times the flow rate fell into each distribution column, row. How often it was in that column. So we're just tallying them. 11 represents 11 instances at which it had really low flow. And there was one instance where it had really high flow, is basically what we're saying there. Okay, so hopefully we have no problem with that. Now we need to graph it. Unfortunately, this is probably on the back for you, so you might need to either take a picture of it, have it beside you, or constantly flip back and forth or something like that. Okay, histogram. Do we know what a histogram is? Histogram is a lot like a bar graph, and a lot of people just call them bar graphs, but it's a little bit different than a bar graph. A bar graph is where all the categories are completely separate from one another. So it's something like pizza versus hot dogs versus ice cream or something like that. You can do that with a bar graph, and each bar represents how many people chose it, and each bar would be completely separate. A histogram is a breakdown where it really is divided all up through numbers, and it kind of flows. Basically, that's why I think of it. It's a bar graph that flows. So we want to make a histogram of this. We're going to put water flow on the bottom, because that's the thing that we were actually tallying. That's going to be the thing that decides. And it was in meters cubed per second. I'll talk about all the marking points after this, but I am picky with graphs. If you're going to do a graph, you should do it right. Number of years should be over here. You don't need units there because it self-implies what units it is. So now, the bottom, we want to skip a bit at the beginning. And the way we do that is down, skip, skip, skip. So we're not going to actually start this graph at 0. We're going to kind of jump right to the first number that we have. So right here, we actually start at 150. And then we'll just do a new number every single line. So I don't really need to do that. This one should be 600. This one's going to be 1050. And then maybe we'll label every other line. You want these things to look pretty. You don't want them to be impossible to read. Some people like alternate layers, so 600's up high, 1050's down low. But since every line is the same amount, going up by 450, we can skip some lines. So this one should be 1950. Next one should be 2850. If I'm counting right, yeah. This one here should be 33. This one here should be 42. And the last one is 4650. We actually have all these individual columns. Okay, so that's our x-axis, or our independent variable, and then we need number of years where it occurred. It's not number of people, the instances where each year where it occurred. So number of years, and this one, we don't need anything fancy. It can just go up 0 to 2, 4, 6, 8, 10, 12. I think this is actually the hardest part of making a graph, is making sure you pick good numbers. I did that fairly quick. Usually you're going to actually have to calculate how many different numbers you need across the bottom and how many lines you actually have. So in this case, we actually had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different categories. And there was about like 14 lines across the bottom. So that was a pretty easy answer. One line for every category, for every kind of marker that we had. And same thing with going up. We needed 12 possible. We need 11 possible, and it goes up to like 13 or something. So 1 per works out really well. Okay, we make the bar graph now. So you should always do this with a ruler. Where did my straight edge go? Right here. And we need to go up to 11. Sometimes I do the top first, so I know where to stop it. So my first category goes up to 11. So it's going to go there. My second category only goes up to 9. Third category goes to 6. Something like that, and then we're going to fill in those bars. Okay, so start making it on your own. I'm going to keep working here, and then you can check your work after. It does take a while, but you do need to practice this, because you probably haven't made a graph in quite a while. I guess I need to find out how high the next one is. I just found out I counted wrong. These numbers at the bottom I did wrong. So hopefully you didn't copy them. Yeah, I'm going to have to erase these things. Hopefully you get white out or something like that. So that was 28. So then 2 past that should be 37. 28 to 33. 33 to 37. 50. And then, so this is my last one actually at 42 to 46. I think I got that wrong. Anyway. So it should look something like that, and then usually we add a little bit of color in there or something. Okay. Every time I try and judge. So this is 15 minutes now. I'm going to start talking about the end of this. Hopefully you had enough time. If not, pause it and finish your graph. You really should practice this because you need to make a good graph. Every time I'm judging these, I'm always looking in my head for one big thing. I like to pretend that you're in a business meeting and you need to present the data. And do people understand it? It needs to be clear, quickly understandable, and accurate. It needs to have all of those things. You need to be able to put this on a board and people just look at it and be able to grab information out of it really, really easily. These numbers are kind of not so great. I wish there was a way to write them like diagonal. If I was doing a professional meeting, I'd want to write them a bit better, especially over here. This is kind of a nightmare. So that's not so great. I don't like the messed up line I did here. But really those aren't too bad if you're doing it by hand. Most people will do this on a computer these days, so it's kind of a dead thing. For marking it, I always mark these things with 5 points. So you get 1 point if you selected the bottom. You have a title down there, you have units down there, and you've thought of a good axis. The numbers are lined up well. 1 mark for doing the same thing on the side. It's got a title with units, and the numbers are chosen wisely. So they're not jumping around. I've seen some people do like 2, 3, 8, 9, 11, because that's the values they had. You do not skip numbers. You need the numbers to make sense. I need to be able to easily tell that this is only a little bit higher than this. You don't want this to be 50 and this to be like 20, because that's going to be confusing. So 1, 1, 2 for good data. So is the data clear? Is the data accurate? 2 marks for that. And then there's 1 more mark, and that's something we're missing. You're going to take your ruler. You're going to make a nice little underline at the top. And you have to have a title. We need to look and see what data you're actually presenting to us really quickly. So this is Red River flow rates. In Winnipeg. And we might even put years in there. 1950 till 1999. So really nice, not overly long. We're not telling a story. We just want the essential data. So I'm looking at flow rates in Winnipeg over this period of time. And clearly flow rates are going down is something you might be able to say. Actually, this isn't based on, this is how much the flow rates are. This isn't years, so be careful. I thought this was going to be years, so it's going down with time. Nope, this is how often the flow rates are. So very often there's very low flow rates. Actually, most common is somewhere around the middle, and really high flow rates is rare, but it did happen once. Okay, so that is a histogram. And that's our 5th mark. You have to have a good title. And I don't give in on that one. If you don't have a title, if it's not underlined, you lose half a mark. If you don't have a title, you lose a whole mark. And that's 1 out of 5, so it adds up. We're not going to ask for a lot of graphs, but if I ask for a graph, you have to do it well. The other thing I might say is sketch. Probably not in this unit, but in other units, I would use the word sketch. And a sketch, I don't care about all these details. It doesn't have to be perfect. It's not like you're presenting it to a board at a business meeting. It's just a quick understanding of what it looks like in a sketch. So the sketch is just get the data there as quickly as you can. But a graph, you need to make it look good. Okay, what is a frequency polygon? Okay, this time, what we're going to be doing, it's going to be very similar. This axis is going to be exactly the same. This is going to be number of years. And we're going to go 0, 2, 4, 6, 8, 10, 12. So nothing's changing there. But across the bottom, this time, I would actually set up the numbers. I'm going to do it a little bit differently this time. I'm just going to set them up, not with our actual intervals this time, but actual numbers now. Okay, so we need to get up to about 5,000. Yeah, right? And how many lines do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines to get up to 5,000. So every line could be 500. So every 2 lines is 1,000. So it would take 10 lines to get to 5,000 then. I think that would work. So that's what I'm going to do. Again, this is going to be water flow in meters cubed per second. And I'm going to call that 500, so I'm going to call this one 1,000. 2,000. 3,000. 4,000. 5,000. And then we won't really need beyond there, so we'll have a bit of spare room on the graph. Some people, I forgot to mention this, if you don't want to write so many numbers, some people say this is in thousands of meters cubed per second, in which case they could just write 1, 2, 3, 4, 5. And that means 1,000, 2,000, 3,000. So if you have really big numbers, that's kind of a way of cheating. You definitely see that when it's like in the millions and stuff. Then they'll say the units is per million or something. And then every number is at many millions. But this one, 1,000, is not too hard to write. Okay, now what we need to do is this. This is actually going to be like a line graph. The polygon is going to be very similar to a line graph, but we're actually going to use our tallied data for this one. Let me kind of bring it up on the side here so we can see. Okay, so I've got all my different tallied data over here, and we're going to be putting this onto the chart. Now, my first one is for an entire range from 150 to 600, and I need to make it up to the height of 11 there. Now, where am I actually going to put that if it's only going to be a point? And the answer is you need to find the middle of the interval if you're going to do a polygon. So for the middle of 150 to 600, you could do that a lot of different ways. I wonder if you can do that nice and quickly in your head. One way you might do it is you would find out how big the range is. So maybe you would do 600, take away 150. So you'd find out it's a range of 450. You'd maybe divide that by 2 because you want halfway. You'd say it's 225. Now that isn't your answer. It should be 225 past 150. So then you'd have to add the original 150. And that should get our midpoint of 375. That's kind of an intuitive way to do it. Here's the other way to do it, and this is called the average formula. And this really isn't stressed enough in high school, but this actually comes up over and over and over again. So to find the average of two numbers, I like to think of it like Halloween candy. So you have a younger brother, he brought home 150 Halloween candy, you brought home 600 Halloween candy, and now you need to share it evenly between you. You want to average that number, and each of you take it away. So what do you do to your Halloween candy? Well, you throw it all into a big pile, and then you cut it into 2. Right? That's the way I think of average formula every single time. So if I took these 2 pieces of candy, I would throw them into a big pile, which means add them together. So together, you have 750 candy. And then you just cut it right down the middle, and that gets you your average. Everyone should go home with 375. Okay, do that for the rest of the numbers. At least do that for a couple more. Make sure you can do it. Add them together, divide by 2. And you should get these numbers on the left here. Okay, I'm going to keep going so this video isn't so long. And then we just make a point on the graph. So 375 should have a height of 11. So that's 500. So 375 is around here up to 11. Something like that. 825 has a height of 9. Something like that. 1275, just past halfway here, has a height of 6. Okay, and keep going and making those dots. we're going actually a little bit backwards in the interval each time. We started pretty far right and then progressed towards the middle. Now we're past the middle to the left, past the middle to the left. So eventually we should end up on the line, if my math is right. 26, 25 is 2. That one's almost on the line. And now we're on the other side. Oh, I skipped one. 3,075. Is that 3? So it should look something like that. And it's not very pretty yet. And then all we do is actually just connect the dots. So it is a lot like a line graph. So again, make sure you use a ruler. I don't like to, it really bothers me when I see these things freehand. Wish I had a better ruler. And make sure you don't skip a dot. Don't connect like these two. That would be a horrible mistake. Make sure you connect them in order. This is a horrible ruler. You're going to do a better job than me, hopefully. Okay, and then we'd also put a title here as well, but we'll kind of add an underline. We'd probably call it the same title as last time. So that is called a frequency polygon. It's a polygon because it's an enclosed figure with straight lines. Not really, you'd have to kind of loop it back to the beginning to make a polygon, but they call it a polygon anyway. Yeah, that's it for that one. Okay, finishing up this page. Let's see if we can analyze some of these graphs. Actually, I think I'm going to leave this to you guys. This is a good way of checking your knowledge, and people usually like these. This one's just analyze the graphs, see if you can understand them. If you have any trouble with this, ask me, and I can walk you through it. I probably should be done the 20-1s lesson by now. Okay, good luck.